Hello, I'm here to help you with your assignment. I thought that I could go through the way to solve these 3 questions, and then if I videotaped it, then that way you could be able to play it a few times, and so you could make sure you understand the concept. Hopefully you'll be able to see it as well too as we videotape this. All right, the first question is about Will Sahachian. Will Sahachian was throwing a cracked egg at a tree outside of the classroom. The egg has a mass of 0.065 kilograms. So first of all, anything you do, anything you see, write it down in the method. Okay? So I know that the mass is 0.065 kilograms. Okay? All right, next. If the egg started from 0, okay, so what does that mean? That means the initial velocity must have been 0. Okay? And it left his hand with a velocity of 22.2 meters per second. So VF would have been 22.2 meters per second. All right, during the throwing time of 0.21 seconds. So now I've got a time as well, 0.21 seconds. All right, what's the average force that will apply to the egg? All right, so if I want force, I know I have to use F equals ma, okay? All right, look, F net equals ma. The problem is I've got the mass, but I don't have the acceleration. So I've got this, but I need a. I don't have that. So I can use the other part of the information to be able to get a. I can go like this. I'm going to write it real small or write up close so you can see it. VF equals VI plus AT. I know this is 0. My bad, excuse me. I know this is 22.2. 22.2 equals 0 plus A times 0.21. 0.21. All right, so solving for A then. I'm just going to take 22.2 divided by 22.2 divided by 0.21. Comes out to be 106 basically. So the acceleration is 106 meters per second squared. I can write it right there to make sure that I have it so I can use it for next time. All right, now I can put it right there. 106. So now F net equals ma. All I have to do is take 0.065 times 106. 106 times 0.065. So that comes out to be 6.89 newtons. Okay? All right? So that's how you do the first problem. I'm going to check just to make sure that everything can be seen on that film. All right, let's get ready to do question number 2 now. Question number 2. Jack was riding a new bicycle at a velocity of 8.5 meters per second. So let's write that down. I know it's a velocity of some type. 8.5 meters per second. He slammed on his brakes, so evidently this first velocity was the initial velocity. So he slammed on his brakes to leave a cool skid mark to impress the ladies. If Jack and the bike have a mass of 65.0 kilograms, so I've got mass is 65.0 kilograms, and he leaves a skid mark that's 2.8 meters long. So really what that is that's how far it took him to stop, 2.8 meters. What average force did Jack's tires apply? So I want the force did they apply to the ground. Assume that the time of stopping, so evidently he stopped, VF is 0, and the time was 0.659 seconds. All right. So what I want is I want the force, okay? So again, this is one of those things where I need F equals ma, okay? F net equals ma. Now actually there's two ways I could get the acceleration. See, because I know the mass of Jack and the bike is 65. So how do I get that acceleration? I could go like this. And I could find the acceleration because I know this is 2.8. This was 8.5. This is 0.659. That's 0.5. That's my variable. And then again, this is 0.659. So I could do it that way. But if you look also, I could also go like this. VF equals VI plus AT. See, I have VF, I have VI, and I have T. So that's probably the easier way to do it. So let's just do it that way. The final velocity was 0. Okay, the initial velocity was 8.5 plus A times 0.659. Now, you know, algebraically, we're going to put this on the other side, and it's going to be negative 8.5 is equal to A times 0.659. So the acceleration is going to come out negative because he's stopping. He's slowing down, okay? The force is also going to come out negative too because of that, won't it? So 8.5 divided by 0.659 equals negative 12.89. Okay, that's good enough right there. All right, now let's put that over here. Negative 12.89. I take this times this. 65 times 12.89, that's negative, and it comes out to be this, 838 newtons. Okay, and I rounded a little bit. And that's how to do question number 2. Okay? You have to use 2 equations, and there'll be something like this on the test, okay? You're going to use one of the kinematic equations to be able to get the acceleration or the force or something like that to be able to find out the force. Okay, now let's get ready for question number 3. All right, question number 3 is very easy. It says, suppose Dion, he has a mass of 55 kilograms. So here's the mass of Dion, 55 kilograms. He's going to become an astronaut and he's going to go to Mars, okay? What would be his force of weight? So this is that FW, okay? Mars only has 1/3 g, so the acceleration is going to be 1/3 of Earth's, okay? So I know FW equals mg, all right? So I could go like this. I can take his mass, 55, times g, which is 9.8, but then I'm going to take it times 1/3, because there's only 1/3 the gravity, okay? So how much would Dion weigh on Mars? Well, he would weigh 55 times 9.8, and then I'm just going to divide it by 3. Okay, so he'd weigh 180 newtons, which is basically, you guys, 1/3 of what he weighs here on the Earth. Okay, I hope this has helped you.